I to j, I to j. Okay, so so on Monday we went through this example, okay, to look for the unit vector. So we went through 3D vectors, right, on Monday. Yeah, and we stopped here. So yeah, so this example I've gone through with you, and we almost reached the answer. Well, that's literally the answer. You just have to finish up the square root, the things inside the square root, and then you're gonna get the final answer. Okay, so nothing for me to go through here. Okay, so for today, today we're gonna jump into a subtopic within vectors. Okay, so another subtopic within vectors. This one's called the dot product. Okay. Wait, I think I'll flip my phone. I'll flip my tablet the other way around so I can write more. Okay. I flip my tablet the other way around. Okay. So you flip your phone as well. Huh? Okay. So today we're going to talk about the dot product. No, not project. Okay. Today we're going to talk about the dot product. So what is the dot product? So the dot product is a way in which you can use to multiply vectors. Okay, so when I say multiply vectors, what I mean is you have one vector, you multiply it with another vector. Okay, so this is different. Huh? This is different from what we did previously. So previously what we did was we may have a vector like that. So previously what we did was we may have a vector like that. 2j minus 3, sorry, 2i minus 2j plus 3k. So maybe something like that previously. Okay, so you can multiply this with a scalar value. Okay, then you're gonna get 4i minus 4j minus 6k. Okay, things like that. Now this is just a vector multiplied by a scalar. Okay, a vector multiplied by a scalar, so you get a vector answer. Okay, now what we are doing today is different. What we are doing today is vector multiplied by vector. Okay, so the dot product is one way in which you can multiply two vectors together. Well, two or more vectors together. Okay, now later on we are going to talk about another subtopic which is called the cross product. This is another way in which you can use to multiply vectors. So these are the two ways lah. These are the two ways used to multiply two or more vectors together. Okay, so when I say the dot product, what I mean would be then is, let's say you have a vector A, you dot vector B. Okay, that's the dot product literally. Okay, vector A dot vector B dot product, and then a cross product is literally vector A cross vector B. Okay, that's the definition now. The difference in definition between the two. Okay, one of them is literally a dot, the other one is literally a cross. Okay, so today we're going to talk about the first one, the dot product first. Okay, so today we are going to talk about the dot product first. It's also the easier one to do that. Okay, it's slightly easier. Okay, okay. Right, okay, so the dot product, what it does is it adds, adds at the products of corresponding components of two vectors. Okay, so it adds the product of corresponding components of two vectors. Okay, so because of that, the answer, so when you do a dot product, okay, what you get is the answer is going to be in the form of a scalar. You won't get a vector out of it. Basically, it's a round number. You're going to get round number as an answer. Okay, it will not give you a vector. Okay, so example is like that. Okay, so let's say I have a vector A, which is A1, A2, A3. Okay, and a vector B, which is B1, B2, B3. Okay, so I have two vectors here. When I dot product these two vectors together, what I get is A1 times B1 plus A2 times B2 plus A3 times B3. Okay, so what you get in the end is you get a scalar, or a integer, a number. Okay, you don't get a vector. Okay, so we'll do a quick short example to demonstrate this. So let's say I have a vector here, vector V. Vector V is 2i minus 3j plus k, and a vector W, which is negative I plus 2j, 2 minus 2k. Okay, so I have two vectors here. When you dot product the two together, what you get is you basically the first term multiply together. Okay, 2 times negative 1, I'll show you. 2 and negative 1 gives you this, plus negative 3 and 2 plus 1 and negative 2. Okay, I'll underline for you. Okay, so the first one is 2 times negative 1. The second term is negative 3 times positive 2. Yeah. And then the third is 1 times -2. Okay. What's the answer? 2 times -1 is what?
The answer is 10.
Negative?
Negative 10.
Okay. So easy, yeah? Okay, so this one's easy. Everyone gets -10, huh? Okay, this one very easy. So the thing I want to point out is -10 is a scalar. It's a integer. It's a number. Yeah. So you don't get a vector. Okay, that's the point I want to make. Okay. So when you dot product two vectors together, you don't end up with a vector anymore. You end up with with just a number. Okay. Okay. Remember this, huh? When you dot product two vectors together, you end up with a scalar, not a vector anymore. Okay. So if you still end up with a vector, that means you've done something wrong. Okay. So remember this. Okay. So next, I want to go through very quickly properties. The properties of dot product. Okay, properties of a dot product. So there are 1, 2, 3, 4, 5. There are 5 rules. Okay, that govern the behavior of a dot product. First, vector v. If I have a vector v, if I have a vector v times a vector w, you will get the same answer if you do vector w times vector v. Okay, same answer. All right. The second rule is if I have two vectors, vector u plus vector w, and then the whole thing multiplied by vector v, it's the same as vector v dot product with vector u plus vector v dot product with vector w. Okay. Okay, so you can see how that happens. This times that times that, and then you add the two together. Okay, so you add the two together. Yeah. 3. Okay, so the third rule is if I take any scalar, any number, C is a scalar number lah, any number lah. Okay. Any number multiply by a vector, and then so you multiply any vector, so you not multiply a vector with a scalar, and then you dot product the thing with another vector. What you get then is you will get the same answer as if you do the dot product first and then you multiply by the scalar. You will also get the same answer as if you had reversed the process where you multiply by the scalar with w first and then you dot product with v. Okay, it's the same answer. Okay. The fourth rule is if you have a vector that is all 0 inside, so 0i plus 0j plus 0k, you multiply that vector with any vectors, you're gonna get a integer. You end up with a answer 0. Okay, integer of 0. Okay. Finally, the fifth and final rule. Okay. So the final rule is now if you multiply a vector with itself, v times v. Okay, so you dot product. Yeah. So if you dot product a vector with itself, what you get is basically v1 V2, V3 dot product with V1, V2, V3. What you literally get is V1 squared plus V2 squared plus V3 squared. Okay. Yeah, so you end up with this. Okay. Now, there's a relationship that can be drawn here as well. Okay. What is the formula for a magnitude as well? Again, yeah, magnitude. What is formula for magnitude? Just recall. Square root V1 squared V2 squared plus V3 squared. Yeah, this is the formula for a magnitude. Now, do you see relationship? Yeah, the inside part in a formula for magnitude is actually the same as this. Yeah. So what you can do, what you can actually do is, okay, you can say the formula for magnitude is actually square root the dot product of the vector, the dot product of the vector times itself. Okay, or you can rewrite it as the magnitude squared equals to this times this. Okay, so here I pointed out several important relationships. Later on, you will need to like be able to recall this. This is one. This is another one. This is another one. Okay. These are several important relationships which we will revisit in a bit later. Okay. Any questions about this? The 5 rules. Any questions about the 5 rules?
No.
Okay. So in that case, we will go through an example. So, okay, so I have a vector V, 1, -3, 2, and I have a vector W, which is -2, 4, 1, and I have a vector U, which is 2i, minus 4j. Okay. Okay, so I have 3 vectors here. Okay, I have 3 vectors here. Now, I want to point out another thing. Pay attention. Pay attention. I want to point out another thing. You see this vector U here? You remember last week? No, not last week. On Monday. On Monday, we had another thing that has a U term. What is it? What also has a U? What is also known as a U? Last week. Not even last week, Monday.
Unit vector.
Yeah, correct. Unit vector also U kan? But the sign on top is different. What is the sign on top? Macam atap kan? Macam ni kan? Correct? Like a roof. Yeah. Okay, so don't get confused. So don't get confused. If the sign on top is like a roof, then it's a unit vector. If the sign is like that, this is just a normal vector. Okay? Normal vector U. Okay? So don't get confused. This is not unit vector, not it is not a unit vector. Okay. It's only a unit vector if it's U at the top. All right. Okay. So this in this example, we have three vectors, V, W, and U. Okay. Let's do some dot products. Let's do some dot products. So the first one is I want you to do this. Okay. So do this for me. So how do you do this? V dot W plus U. So you have to do the So you have to do the process in the bracket first, the plus. You have to you have to do W plus U first, and then the answer you dot product with V. Okay. So what is vector W plus vector U? So I'm gonna write V first. V is just 1, -3, 2. Okay, what is W plus U? How do you do W plus U again? What is vector W plus vector U? Quick. Marianne, what is vector W plus vector U? Marianne, are you there?
Don't you sum it up?
Yeah?
Just sum the two vectors together. I haven't
Okay.
solved it.
Okay, I can show you very well. So do you have the answer? Do you have the answer?
Okay, wait. Try.
Okay. W plus U. How do you do W plus U?
Is it one, one?
So the first one is what? -1.
Yes, -1.
How did you get -1?
Let's just sum it out.
So it's the sum of what? -2.
-2 plus 2. Oh, astaga. Salah. Salah tinggal.
-2 plus 2.
Yeah. 0.
Okay. Okay. 0. Okay.
Yours.
Yeah, it's 0. Okay. Next one. Yeah, it's okay. Next one.
It's gonna be 4 plus -4, which is 0.
Yeah, very good. 4 plus -4. Yep, 0. Correct. And then next one.
It would be 1 plus.
Yeah. Okay. Okay, good. Okay, good. Thank you. All right. So that. Okay. So that's V plus U. Okay. 0, 0, 2 you end up with. Okay. So now you can dot product with V, which is 1, -3, 2. Okay. So the way you dot product is 1 times 0 plus -3 times 0 plus 2 times 2. Yeah, I will highlight to you what is what is what. Okay, 1, 0 is this. -3 times 0 is this. 2 times 2 is that. So the answer is 0 plus 0 plus 4. So answer is 4. Okay. Next. Same example. But now what I want you to do is V dot product W, and then you dot product U. Okay. So you do V dot product W first. So V dot product W will be and then the whole thing dot product with U. Okay. So you do the V dot W first because it's in brackets. So V dot W is 1 times -2 plus -3 times 4 plus 2 times 1. And then, okay. So what is -1 times 2? -2 plus -12 plus 2. So the answer is -12. Okay. So it's -12 times 2i minus 4j plus k. Okay. So the answer is you just multiply this in. So it's -24i plus what, 48j minus 12k. Okay. Okay, finally C. This one, I'll give you 5 minutes to do. 5 minutes is enough. Okay. I want you to find for me magnitude of V squared minus W squared plus magnitude of V squared plus W squared. Okay. Give you 5 minutes. You do this for me while I do your attendance thing. Okay, 5 minutes. Okay. Please check your Google Meet chat box, the attendance link. Yeah. Okay. So this is so just to refresh your memory, this is what's known as the law of cosines. Okay. Okay. So what we're doing here is we are going to adapt. Yeah, we are going to adapt this law of cosines to vectors. Okay, to the application of vectors. All right. So the way we're going to do this is we are going to draw the same triangle. Yeah, same triangle, but we are going to replace it with vectors. Okay, so let's call that vector V. And we call that vector W. If this is vector V, if the one on top is vector V, the one below is vector W, then forgot direction arrows. Wait, yeah. Okay, then that vector will be V minus W. Okay. This is from my first lecture. If you forgot how I get V minus W, you can go look up my first lecture notes. Okay. And then the angle between V and W, we're gonna just call it, give it theta. Okay. Just give it theta. Okay. So from here we can draw the exact same relationship. Okay. So this angle is actually A. Yeah. There. From here, A. Yeah, I'm gonna write the equivalent. This is C. This is little b. This is little a. Yeah. So now we are gonna just substitute. We are gonna just substitute vectors into our law of cosines equation. So what you're gonna get is a squared. So the first one, a squared. A squared is in this thing squared. V minus W squared. Yeah. Now it has to be in magnitude. Yes, you see, I put the two lines. It has to be in magnitude. Yeah, because it's a length. Okay. This formula is only applicable to lengths. Okay, length. That's why it has to be in magnitude. Okay. Equals to B squared plus C squared minus 2BC cos A, which is theta, cos theta. Yeah. So this is the exact same formula as the one on top, except I replace everything with vectors. Okay. So what you can do then is you can actually rearrange this. You can eventually rearrange this to get cos theta equals to V dot W divided by this dot this. Okay, eventually. So there is some steps involved. There are some steps to get from this long formula to that short formula, cos theta. I want you to work this out. Okay, I want you to work this out, what the steps are. Okay, you need to know how I get from. You need to know how I get from 1 to 2. Okay, you do this on your own. Okay, you do this on your own. Work out how I got from 1 to 2. Okay, it may come out in test or exam. All right. Okay, so I'm basically telling you is we we end up with a formula to calculate angle. This is basically a formula to calculate angle. You can calculate angle between two vectors, basically. Yeah, you end up with a relationship. Okay, to find the angles between two vectors. However, it's only usable for an angle of 0 degrees to 180 degrees, yeah, or 0 to pi only. Okay, this is only applicable from 0 to pi only. Okay, so next, if theta is 0, what that means is both the vectors, what that means is both vectors are parallel. Yeah, because the angle between them is 0, ma. Yeah, so they are parallel. I.e., what does it mean when both vectors are parallel? They have the same direction. If they have the same direction, that means, yeah, what unit vector is the same. They have the same unit vector. Yeah. Okay. Now, if theta is pi over 2, in other words, 90 degrees, both vectors are perpendicular to each other. In other words, one vector like that, one vector like this. Yeah, 90 degrees. Okay. If theta is pi, that means both vectors are parallel to each other as well, but facing opposite direction. Maksudnya, one vector go that way, one vector go this way. Okay. Okay. There's one last one. What you will find is because when two vectors are parallel, theta is 0. What that also means is if you dot product the two vectors together and you end up with 0, it also means both vectors are parallel to each other. Okay. So let's say I give you a question. I give you two vectors. I ask you to check whether these two vectors are parallel to each other or not. So the quick way to check is, well, there are two ways. One, you can find the angle. Yeah, you can use this formula. Use this cos theta formula to find the angle. If the angle is 0, then 0 or pi, that means they are parallel to each other. Alternatively, what you can do is you can do something even quicker. You do v dot w. If it's 0, that means they are also parallel to each other as well. Okay, so there are two ways of checking. Okay. Oh, actually, no, not parallel. Orthogonal. Orthogonal, not orthogonal. Yeah, that means 90 degrees, 90 degrees. Yeah. So if you do v dot w is 0, that means the two vectors are orthogonal to each other. Not parallel. Yeah, orthogonal. Change, yeah? Bukan parallel, orthogonal. Okay. So let's do an example. Find angle between vector V and vector W Okay, yeah. So find angle between vector V and vector W. Okay. So the formula is this. Okay. So you do vector V dot vector W divided by magnitude of V times the magnitude of W. Okay. So you need to find this. You need to find this. You need to find this. Okay. I give you 5 minutes. You look for me and then I'm going to call your names. Okay, 5 minutes. What is V dot V? Quick. The sooner we finish this, the sooner we can end the class.
4.
So V dot V, again, the answer should be a scalar, an integer, a round number. Okay, so V dot V. Okay, where's my example? Correct. Yeah, 4. Correct. Good. Siapa tu? Siapa tadi? Who is that? Who said 4 just now? Correct, it's correct. I just want to know who.
It's the international student, doctor.
Oh, international student. Okay. Yeah. Okay, Faisal's brother. Okay. All right. Okay, very good. Thank you. 4 is correct. Okay. Next, magnitude of V. Someone else.
Square root 13.
Square root 13, 1, 3,
Yes.
1, 0.
1, 3.
Okay, good. Okay, next, square root V. Square root W. Sorry, vector W. Square root.
Root 6.
Okay, good. Okay, so then you put everything in here. You're gonna get 4 over 13.6, which is 4. Well, don't need lah. Yeah. So let me come down here. So basically, is 4 over square root 13 times square root 6. Okay. So if I ask you to calculate the actual angle, what is the actual angle? It's approximately what? So you have to do 4 divided by square root 13 and then divide it again by square root 6 and then you inverse cos. What's the angle? Well, roughly 63.1 degrees, right? Is that correct?
Yes, doctor.
Okay, good. Thank you. All right. Next, I'm going to leave you. I've got some work to do. I'm going to leave you with a few examples. Should be easy. Okay. You do this for me. Okay. So 2i minus j plus 3k. So I have two vectors, A and B. Okay, so two vectors, A and B. First question. Are vectors A and B parallel or not? Next, are vectors A and B orthogonal or not? Okay. Next, I have another question. I have a vector V, 2, 3, -1, and vector W, 2, -1, 1. Same. Are they parallel? Are they orthogonal? Okay. Can you do this? Do this for me. Okay, in your own time. We have well, technically we have 50 minutes, another 50. We have another 50 minutes till the class ends. Okay, but you finish this, then you can go for, you can do whatever thing you want. Okay, so spend the next 20 minutes lah, or rather 19. Spend the next 19 minutes to do this. At least while things are still fresh in your mind, you do this. Okay, then you can go enjoy your weekends with that. Okay, if you don't have any more classes in the afternoon. Okay, any questions before I end the class?
No questions, Doc.
Okay, no questions. So spend the next 19 minutes do these two questions. Okay, don't go anywhere yet. All right, so I will see you Monday. I will see you Monday face to face again. All right, same place. Okay, so see you. Have a nice weekend.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.